microcosm.
Imagine looking up at the night sky and realizing we're not just gazing into space, we're staring into possibility. For most of human history, we believed Earth was the center of everything. But now, with telescopes that see farther and clearer than ever before, we know better. Planets don't just circle our sun, they orbit stars scattered across the galaxy like cosmic lanterns. And some of those distant worlds might be alive. We call them exoplanets, and while over 5,000 have already been confirmed, only a precious few make our imaginations race. These are the ones nestled in the Goldilocks zone, not too hot, not too cold, where liquid water could exist, and where biology, in all its stubborn brilliance, might just have found a foothold. Let's embark on a journey. 10 worlds, 10 alien frontiers, 10 exoplanets where life, yes, actual life, could already be thriving. First stop, Proxima Centauri b. It's the closest exoplanet we found, just over 4 light-years away. If the Milky Way were a city, Proxima b would be the neighbor across the street. It orbits the red dwarf Proxima Centauri and sits right in the habitable zone. The catch, its star flares with radiation. But what if life there has adapted? Maybe it hides beneath oceans or within thick, shielding atmospheres. Life, after all, is nothing if not resourceful. Next, we drift to TRAPPIST-1e, part of a 7-planet system 40 light-years away. TRAPPIST-1e is rocky, temperate, and similar in size to Earth. It orbits a small, dim star, giving off just enough warmth. And here's the kicker. If there's water there, and we have reasons to believe there might be, it's not just a puddle. It could be an ocean world. Think Earth if the continents were optional. And then there's LHS 1140b, a planet that's basically Earth's bulked-up cousin. It's heavier, denser, and clings to its atmosphere like a cosmic heavyweight. Its parent star is calm and quiet, the type of place where life might have time to grow roots. The planet's gravity could help it hold on to water, and where there's water, well, you know the rest. Now we venture 1,200 light-years to Kepler 452b. Sometimes called Earth's older sibling, it's been around for 6 billion years. That's 1.5 billion years longer than Earth. So if life needs time, this planet's had a head start. More time for evolution, more time for complexity, more time, maybe, for consciousness. Zooming in to TOE 700d, a relatively new find just 100 light-years away. It's Earth-sized, in the habitable zone of a red dwarf, and unlike many red dwarfs, this one seems surprisingly gentle. That gives this world a chance. Maybe its skies are purple with alien flora. Maybe microbial mats ripple beneath shallow seas. Or maybe there are creatures staring up at our sun, wondering if they're alone. Let's take a detour to K2-18b, a super-Earth in the Leo constellation. We found water vapor in its atmosphere. Let me say that again, water vapor. That's one of the biggest clues we've ever had. It's larger than Earth, maybe too big to walk on without feeling like you're wearing lead boots, but if it has a hydrogen-rich atmosphere and water clouds, could it support microbial life floating in the skies, like airborne plankton drifting in a humid alien heaven? Sailing farther, we arrive at Gliese 581d, a planet once dismissed, now reconsidered. It lies on the outer edge of its star's habitable zone. If it has a thick atmosphere, think greenhouse on steroids, it might trap just enough heat. It could be a world of mist and twilight, where hardy life forms cling to warmth like desert creatures clinging to an oasis. Then there's Wolf 1061c, about 13.8 light-years away. It's close enough that in cosmic terms, we could send a probe in a future generation or two. It might have extreme seasons or chaotic climate swings. But what if evolution there embraced the chaos? On Earth, life has conquered everything from freezing tundras to boiling acid lakes. Why should Wolf 1061c be any different? Our ninth candidate, Ross 128b. It orbits a quiet red dwarf just 11 light-years away. No violent flares, no stellar tantrums. Peaceful, predictable. That's the kind of place where life could settle down, dig in, and maybe flourish. If the right molecules danced together in just the right soup, who knows what could have emerged? And finally, we gaze toward Kepler 442b, about 1,200 light-years away, and possibly one of the most Earth-like planets we've found. Rocky, temperate, bathed in just the right amount of starlight. If life ever sparked there, even the simplest kind, it might still be there, evolving, multiplying, adapting, waiting. And here's the cosmic truth. Every single one of these worlds is a natural experiment. Nature doesn't try something once, it tries it everywhere. So why should Earth
be the
only story in
the
the universe
at,
where chemistry became biology and biology
a staggering,
dared to
breathtaking
dream?
diversity of planets, stars, systems, and phenomena. And when it comes to exoplanets, the cosmos doesn't play favorites. It crafts fiery lava worlds, ice giants, cloud-wrapped gas spheres, and, every now and then, something oddly familiar. Something that tickles the imagination. Now picture a world not lit by a yellow sun like ours, but by a deep red ember. A world where daylight is a dim glow, where shadows stretch endlessly, and life, if it exists, has adapted not to brightness, but to perpetual twilight. This isn't science fiction. It's the reality of many red dwarf systems. These stars are ancient, long-lived and stable, and the planets around them could be the galaxy's quiet, long-burning cradles of life. Some of these exoplanets are likely tidally locked, one face always toward the star, the other plunged into eternal night. Harsh, yes, but not impossible. On such worlds, there might be a twilight band, a ring around the planet where conditions are just right, neither scorched nor frozen. Just warm enough for water, just calm enough for chemistry. An entire civilization could bloom within that narrow sliver between extremes. A civilization that has never seen the stars move, never known a sunrise, only the constant glow of their parent sun hanging motionless in the sky. And consider ocean worlds, planets entirely covered in liquid. No continents, no mountains, no dry land. Just water, horizon to horizon. On Earth, life began in the oceans. Perhaps it always does. So what might evolve on a world with no land to climb onto? Would evolution press forward endlessly beneath the waves? Intelligent beings that never discovered fire, never built wheels, but mastered sound, pressure, bioluminescence. A civilization born in silence, with technology sculpted from coral and light. Now, flip that. Imagine desert planets, scorched, dry, cracked, with atmospheres barely clinging to their rocky surfaces. Barren? Maybe. But here on Earth, life thrives in the Atacama Desert, in the dry valleys of Antarctica, in salt flats where nothing should live, and yet it does. So, perhaps on a planet of sand and dust, life has simply gone underground, shielded from the radiation, hidden from the wind, thriving in pockets where heat and chemistry meet beneath the crust. Then there are the super-Earths, massive rocky worlds with stronger gravity, thicker atmospheres, and unfamiliar landscapes. Some of them may have weather systems unlike anything on Earth, with metallic rains, supersonic winds, or clouds that glow in alien colors. But if they're in that sweet spot, the habitable zone, and they're stable enough for water to remain liquid, then all bets are off. Life may not need Earth-like conditions, just Earth-like opportunity. Picture a moon orbiting a gas giant, like our own Europa or Enceladus, but bigger, warmer, closer to its star. These moons, technically not even planets, could steal the show. Tidal forces from the massive planet could keep their interiors warm, stirring oceans beneath icy crusts. Volcanic vents might churn out nutrients. Imagine a biosphere thriving, not thanks to starlight, but to gravitational heat. Now stretch your imagination further. What if life doesn't even need water? What if, on some of these exotic worlds, life has taken root in methane or ammonia seas, using chemistry we haven't even considered? On Titan's moon, we see rivers and lakes made of methane. Could an exoplanet be Titan's big brother? A fully fledged methane world where life has evolved to thrive in freezing alien conditions. The possibilities are endless, not because we're making them up, but because the universe is making them real. Every exoplanet we catalog adds to the grand experiment. And with every discovery, we get closer to answering a question that has echoed across generations, across cultures, across history. Are we alone? We've only just begun to listen, only just begun to look, and already the universe is whispering, there are other worlds, and some of them might be alive.